In this video, I have want to use what's called the ratio test to show that this infinite series converges, and then show that it converges to 12. And so just let a sub n be the expression n times 3/4 to the n. And so a sub n plus 1. So in the place of n, we just replace it with n plus 1. And then the ratio for a sub n plus 1 over and a sub n, it'd be n plus 1, and then 3/4 n to the n plus 1, dividing by n times 3/4 to the n. And then here we have n plus 1 over n, and then 3/4 to the n plus 1, dividing by 3/4 to the n. Then we just get 3/4 to the first. So it's n plus 1 minus n, and we get 3/4 to the first, which is 3/4. And then the limit of the ratio a sub n plus 1 over a sub n is n approaches infinity. It'd be just the limit of this expression here. And then this is the constant 3/4, so we can move it and place it in front of the limit. And then what we can do for this expression here, divide everything on the top by n, and then divide everything on the bottom by n. So n dividing by n is 1. 1 over n is just 1 over n. And then n dividing by n is just 1. And then we can see that as n approaches infinity, then 1 over n approaches 0. So this entire expression will approach 1. So we get 3/4 times 1, which is 3/4, which is less than 1. And therefore, by the ratio test, which says that if the limit of the ratio a sub n plus 1 over a sub n, if this limit here is less than 1, this series converges. And so now we know that this series converges to some finite number. And let's find that number. And now we want to show that this infinite series here converges to 12. And so writing out the terms here, when n is 1, we get 3/4. When n is 2, then we get 18 over 16. When n is 3, we get 81 over 64, and so on. And so let's call this sum right here, let's call it S. And then what I want to do here is I'm going to multiply S by 4/3, which is the reciprocal of 3/4 here. And so multiplying this sum right here by 4/3, then we get 1 plus 6 over 4 plus 27 over 16, 100 plus 108 over 64, and so on. Now let's do 4/3 S minus S. So it's this sum minus this sum. So here we get 1 6/4 minus 3/4 is 3/4. 27 over 16 minus 18 over 16 is 9 over 16. And then we get 27 over 64 plus 81 over 256, and so on. 4/3 S minus S is 1/3 S. This is 1. And then we can write the, for this part right here, we can write it as the summation with the expression 3/4 to the n. And we can see that when n is 1, we get 3/4. When n is 2, we get 9/16, and so on. This series right here, this is a geometric series with the first term of 3/4 and a common ratio of 3/4. And therefore 1/3 s is equal to 1, and then this is the geometric series, so we get 1 plus 3/4 over 1 minus 3/4, which is equal to 4. So 1/3 s equal to 4, and then multiply both sides by 3. We get s to be 12. But s is this sum right here. So this infinite series here is equal to 12. And therefore, and then in summary, so we have just shown that, I've just shown that this series here converges by the ratio test. And then I've also shown that it converges to 12. And that's the end of the video.